Hello everyone, this is Steve Suffoletto from Mary Community College, just south of Buffalo, New York. This presentation is a follow-up to an earlier post titled The Physics of Light that was posted to YouTube on November 28, 2020, just after Thanksgiving. So I want to fill out this table, and we have three conditions. We have a white, a gray, and a black. We know that white reflects 100% of the light. Black would reflect no light, and halfway between white and black is one halfway between 0 and 100 would be 50%. Now we also know that the opposite of reflection is absorption, so the opposite of 100 would be 0, and the opposite of a 0 would be 100, and the opposite of 50 is 50. So for relative change or difference, we would say that white is lighter, black is darker, and we'll use gray as the reference. Now in an image scene, these would be the highlight. This would be the shadows. And this would be the midtones. By the way, in photography, this would be the 18% reflectance, which is about a density of 70. Now in photography, we also have keys. Key is the lighting technique or the lighting style. If you're predominantly highlights, we would call this a high key. If you're predominantly shadows, we would call this a low key. And if you have both highlights and shadows, it would be normal key. So if you take this analog, traditional photographic photography, film-based or print-based, and you now convert it into digital, and you use a 8-bit byte, then when you're black, you have a 0 pixel, and when you're white, you have a 255 pixel value. Now, if you count the 0 as a number, it becomes 256. And halfway between 0 and 255 would be 128. Just to be clear here, this is base 2 raised to the power or the exponent of 8. That would equal 256 gray levels. Okay, now dot area. If you're white, you want to be 0% dot. That's just bare paper. If you're black, you want to be 100% dot, which is solid ink. And of course, halfway between bare blank paper and solid ink would be a 50% dot. So that's a screen tint. So relatively, this would be a small dot. This would be somewhere between 1 and 10% in terms of highlights. This would be, the shadows would obviously be a large dot, somewhere between, say, 85 and 99%. And this would be a medium dot, let's say 50 plus or minus 10, which would give you a range of 40 to 60%. Now, if you take a reflection densitometer and measure paper, it'll probably be somewhere around 0.05. And that is if the paper is like around a 95% brightness. If you measure the black, ink, the black ink will be somewhere, if you're coated paper, you're probably around 190. If you're matte paper, you're probably around 150. And if you're uncoated paper, you're probably around 125. And these are all for wet densities, right? So the D max, the maximum density, is probably going to be less than 2.0. So what would be the reflection density for a 50% dot? We already know it here, and that's actually not correct. That number probably should be, let's make that number 0.74. So you could come over here and say it should be about 0.74. But if you follow GRACO, which is the general requirements for the applications of commercial offset lithography, and you follow G7, they often say that your midtone density should be somewhere around 0.67. But if you add in the paper 0.05, you get 0.72, which is close to 74. So that's absolute plus the paper. This is relative minus the paper. And then finally, if we go into colorimetry, we would measure C-lab, L star, A star, B star. So the L star is lightness and darkness. So if you have a white, your L star is going to be near 100. And if you have a black, your L star is going to be near 0. And in theory, your midtone gray should be somewhere around a 50. Okay, so this table here is, again, metrics for tone reproduction. So reflectance is 1 minus the absorption, and absorption is 1 minus the reflection. And the highlights can be abbreviated with an H. These are the lighter tones. The midtones can be abbreviated with an M, and the shadows can be abbreviated with an S. And just to make sure we haven't forgotten anything here, at the very bottom of my table here, we talk about how light interacts with matter. It can either be reflected, absorbed, or transmitted. The reflection can be either specular or it can be diffused. And we know that the formula for density is the minus log of reflectance. And if you know the density, you can take the anti-log of it to get the reflectance. And the formula for gray level is simply 255 minus 255 times the dot size area. Okay, so this table, once again, is a summary of everything that we've learned in the video called Physics of Light. As always, thank you for attending and participating in this video. I hope you found it interesting, informative, and we'll see you soon. Bye now.